Hello, welcome back. We're going to continue on with our antiderivative of base e. For number 4, we have this antiderivative of e to the 2x over 1 plus e to the 2x. This one is a slightly more challenging one, like what do you want to be for our u in this case? So I'm going to play around a little bit. For example, I'm going to pretend like I'm going to let u equal this e to the 2x on bottom. There's nothing wrong with doing this. We would get our derivative would be e to the 2x times 2 dx. Don't forget your chain rule. So we would get dx is equal to du over e to the 2x times 2. And if I were to substitute this in, we would get e to the 2x over 1 plus u. Now notice, I did let it be e to the 2x, but I only substituted for the bottom one. Let's see why I would do that. I would get du over e to the 2x times 2. Ah, those are just going to cancel out. And what I'm left with is this integral of 1 half 1 over 1 plus u du. So I'm going to go ahead and cheat a little bit. We've been doing this for a little while now. If I notice the entire bottom has a power of 1, I know that this is just my natural log. So my answer is going to be 1 half the natural log of 1 plus u plus c1. If I replace my u, we get 1 half the natural log of 1 plus e to the 2x plus c1. That is not the only way to do this one. Option 2, let u equal the entire bottom. My derivative is actually still the same thing, e to the 2x times 2 dx, giving us dx is du over e to the 2x times 2. But when I rewrite it, I'm going to get this e to the 2x over u times du over e to the 2x times 2. And again, those cancel, and I'm left with 1 half 1 over u du. And if you notice, this will become the exact same answer. So you have a couple of options sometimes. It's really just dependent on really how good your algebra is and how much you want to practice these. All right, number 5. This one's like my favorite. I love trig problems. So again, which one's going to be u? Anytime you have an exponential function, your u is generally your exponent itself. So we're going to let u equal cosine of x. Be careful with the derivative. We get negative sine of x dx, giving us dx is du over negative sine of x. When I rewrite our integral, we're going to get the sine of x e to the u du over negative sine of x. Those cancel out. Be careful, we're left with this negative e to the u du, and our antiderivative is negative e to the u, the antiderivative e to the u is e to the u, plus, whoops, excuse me, pen trouble here, plus c1. Replace u, e to the cosine of x, plus c1. And there's your antiderivative. Very easy to do. Number 6, here we go. Let's try this one here. This is again a u substitution problem, but we're going to let u be the whole bottom here. Now you may be asking, why do I know that? Well, the derivative of e to the x is just e to the x. When I take the derivative with a 2, I can bring that down. And notice, if I multiply this entire quantity here by 2, I know it's going to cancel the top. So I'm going to let u be the entire bottom. E to the x plus e to the negative x squared. The derivative becomes 2 e to the x plus e to the negative x to the first, but the derivative of the inside becomes e to the x minus e to the negative x. I'm starting to kind of see a problem right here. I might be wrong, but let's take a look at why I'm wrong. I know that I can cancel a little bit out. I can cancel out this e to the x minus e to the negative x with the numerator, but I'm still left with this on the bottom. So that's kind of telling me that this is not the right way to do it. So I'm going to go ahead and erase that and choose a different u here. So instead of doing the whole bottom for this one, see, it's okay to be wrong. I was just wrong there too. And it's okay to have errors. They're awesome. Helps us learn more. I'm going to let u actually just equal the inside of the bottom, e to the x plus e to the negative x. The derivative is e to the x plus e to the negative x times the negative 1 dx. And if I simplify that, we just get du over e to the x minus e to the negative x. When I rewrite it, on the top here, I can factor out my 2. This seems a little bit more reasonable than what I had before. Over u squared du over e to the x minus e to the negative x. Those cancel, and what I'm left with is 2u to the negative 2. Be careful, this is not natural log. This is just my power rule. We get 2u to the negative 1 over negative 1 plus c1, or negative 2 over u plus c1, which is just negative 2 over e to the x plus e to the negative x plus c1. A little bit of algebra right there. Number 7, this is with our domain. This is no plus c's here. I'm going to let u be my x cubed. We got x squared e to the x cubed. The derivative of x cubed is 3x squared. That x squared will cancel with this x squared. So I can go and verify that. Let u equal x cubed. Du is 3x squared dx. Dx is du over 3x squared. When I rewrite this, we're going to get x squared e to the u du over 3x squared. X squareds cancel. We're left with 1/3 e to the u du. Go ahead and change your domain. When x is negative 2, u is negative 8 because it's negative 2 cubed, which is negative 8. When x is 0, u is 0 cubed, which is just 0. So there's my new domain. Integrating it, we get 1/3 e to the u. I don't have to replace u now because I changed my domain. Remember, my domains are now in terms of u. From negative 8 to 0, we get f of 0 minus f of negative 8. And f of 0 is 1/3 e to the 0 minus 1/3 e to the negative 8. E to the 0 is just 1, so 1/3 minus 1/3 e to the negative 8. Leave your answer like though. That's fine. All right, so go ahead and try number 8 here. I'll go and do it too. Let your u be your exponent. U is 3 minus x. Du is negative dx, so dx is negative du. When we rewrite it, we're going to get e to the u, negative du. And I'm going to go and change my bounds here. When x is 3, u is 3 minus 3 is 0. And when x is 4, u is 1. So we're going from 0 to 1. I don't have to rewrite anything. I could just take my integral. We're going to get negative e to the u. Don't forget that negative. My u looks terrible there. From 0 to 1. Using your FTC, f of 1 minus f naught, f of 0. We're going to get negative e to the 1 minus negative e to the 0. So we get negative e to the first plus 1. Remember, that's just 1 right there. And there's our antiderivative. All right, hope you guys enjoyed the video, and smash that like button. I'll see you later. Bye-bye.